So substitution. So solving systems of equations by substitution. When you substitute for something, what does that mean you do? Fill it in, you replace it, right? So somebody subs in the basketball game, you replace the player, right? So that's what we're going to be doing with this. So we're going to start off with this problem. 3x plus 5y equals 17, all right? And then the second equation, since the system, you got two equations, is just y equals 4. So when we had this problem the last couple of days, we've been solving with graphing. You wanted to graph each of those. Well, today you're not graphing, so you don't have to get y by itself on both problems. Okay. With this problem, what you want to do with substitution, the main idea is look for one of the equations that may have a variable already by itself or easy to solve for. Okay. So with this system of equations, we've got the second equation that says y equals 4. So it's already got something for y. What we're going to do is we're going to substitute what it says y is for y in the other problem. Okay, so we're going to do that replacement with that. So we're going to take this 4, and we're going to substitute it for the y in that equation. That's what we're going to do. Okay, and when we do that, we get 3x plus 5 times 4 equals 17. So we get this equation that now only has one variable in it. It's got x in it. Okay? Let's solve that equation. So multiply 5 times 4 first. Let's do that first. And that'll get us 3x plus 20 equals 17. Now what? Subtract 20 because we want to get x by itself, and 20 doesn't have an x. It's like the 17. So we're going to subtract 20 from both sides. And so that'd be negative 3. Still got 3x because the 20s cancel out. How do we get x by itself now? Divided by 3. X is equal to negative 1. So we get x is negative 1. We've already got y. They told us y was 4. So we get this ordered pair solution, negative 1, 4. That's the ordered pair solution. When we're solving a system by graphing, what were the 3 scenarios that could happen? The 3 types of solutions we could have yesterday. If the lines crossed, you had how many solutions? 1. Okay. If the lines were parallel, you had no solutions because they never crossed, right? Or if the lines landed right on top of one another, that was called infinitely many solutions. Okay. Those same 3 scenarios can happen with substitution. This is one of those that we have 1 solution. Okay. So if we had done this one by graphing, they would have crossed at negative 1, 4. That's the tie together with what we were doing yesterday. So we're solving a system. We're just using algebra instead of graphing. Because graphing, sometimes it takes up a lot of paper. It takes a while. You got to move all the equations around, get y by itself. Sometimes it's a little too much, okay? And sometimes it's hard. If they don't cross at a nice point, you got to estimate where they're crossing at, like if it's in between points. So that's hard to do, okay? So we're using algebra to help us get those exact points. Let's look at this system. X equals negative 5 and 2x minus 3y is equal to 11. Okay. All right, so we've got a system here. Do we have one of our variables already solved for? Yes. Which one? X. We've got x is equal to negative 5. So we can substitute that negative 5 in for x. 2 times negative 5 minus 3y is equal to 11. And then Multiply 2 and negative 5 together, that gives us what? Negative 10 minus 3y is equal to 11. Add 10 to 11. Good job, guys. That's awesome. So negative 3y is equal to what? 11 plus 10 is 21. Now what? Last step. Divide by the negative 3. Y is not positive 7, but negative 7. It's positive 21 divided by negative 3 is negative 7. What's our ordered pair? Negative 5, negative 7. Remember, it's always x, then y. Don't get those mixed up, okay? It's always x, then y. All right. Wonder why we spent a month and a half at the beginning of school solving equations? Because you're going to have to use it a whole lot, okay? So that's why we spent a lot of time doing that, okay? Let's look at this one. A little tougher problem. X plus 2y is equal to 11. Y equals 3x plus 2. A little tougher problem. Don't have just a single number that the other variable is equal to. But we do have an equation where one of the variables is already solved for, right? Okay? We got y is equal to 3x plus 2. So we can take that 3x plus 2 and do what with it? Substitute it for what? For the y in this equation. So we're going to take 3x plus 2. We'll put it in for y in that equation. Okay? So that's going to be x plus 2. And this is where you want to put parentheses. 3x plus 2. And that's equal to 11. Okay, so we're taking this first equation and we're substituting this stuff in the place of that y. So it's x plus 2 times what y was, and it's still equal to 11. Okay? So now we solve. So we got to multiply first. So 2 times 3x, 6x plus 4. We still got the x that was out there. Can we simplify that line? We would. We're going to do that eventually. I want to go ahead and put these together first so I don't forget to do that. Yeah, there's a 1 in front of that x. Good, Tom. So 1x plus 6x is 7x plus 4 is equal to 11. And Jackson said we should subtract the 4, which is right. Okay. The next step would be subtract that 4. Use different things there. Minus 4. That's 7x is equal to 7. 11 minus 4 is 7. One more step. Divide by 7. 7 divided by 7 is 1. So x is equal to 1. Now, this one's a little tougher because we don't have what y is already. We've got something that says y equals 3x plus 2, but we don't have the number that is. So what can we do with this 1? We can put it back in. We can substitute with it. So we're going to substitute this 1 into this equation that's got y equals 3x plus 2. We're going to substitute that for x. So that's going to be y is equal to 3 times 1 plus 2. So that'd be 3 plus 2, which is 5. There we have our x and our y. What's the ordered pair? 1, 5. Remember, x is always first, and then y. So a little longer problem, but not incredibly difficult yet. Negative 2x plus y is equal to -3. X equals -3y plus 5. So what can we do with this one? Plug that in for the x, right? That -3y plus 5. Plug that in for x, okay, in the first equation. Taking this, replacing x with it. I'd have -2 parentheses -3y plus 5 plus y is equal to -3. Distribute again. So -2 times -3, positive 6y, -2 times positive 5, -10, and then we still got the plus y that's there. Can we simplify this side? You got a 6y and a 1y. Yeah, they go together, don't they? So that'd be how much? 7y minus 10 equals -3. Add the 10 to the -3. Good job. 7y is equal to, is it -7 or +7? You got a +10 and a -3, so the bigger number was positive, so it's going to be +7 there. Last step, divide by 7, y is equal to 1. How do we get x? Plug it back in. I'm going to plug it into this equation. Technically, you could plug it back into the first equation too. It doesn't matter which one you plug back into. I'm going to use the one that's easier, the second one there. So that'd be x is equal to -3 times 1 plus 5. That'd be -3 plus 5, right? Which is, what's 5 minus 3? 2, same thing. So we got 2 is the x and y is equal to 1. What's the ordered pair? 2, 1. Remember, x always goes first. That ordered pair is the official answer. Okay. X and y we're finding separately. We're going to put them together in an ordered pair for the final answer out of that. Okay. So all 4 of the examples we've done so far, they already had one of the variables by itself for us. Okay. The next one we're going to do is not going to be that way. We'll have to do a little bit of work first. All right. So when you're trying to solve using substitution, you got to have one of the variables by itself to do substitution with it. And it doesn't matter which one you have by itself. But when you're looking at a system of equations, sometimes you can make it easier on yourself to get that variable alone. When I look at these, what you want to look for is a variable that has a 1 in front of it or a -1 in front of it. So the x has a 1 in front of it. So that makes that one easy to solve for. Okay? How do we get x by itself in the first equation? I don't want to subtract x. X has got a 1 in front of it. I want to leave it alone. So I need to move the 2y. I would add 2y. I know we're very used to solving for y. That's what we've kind of conditioned you to want to do. But you don't always have to solve for y. Solving for y can be useful, but it's not something you always have to do. The reason you don't want to solve for y all the time is because sometimes that'll introduce a fraction into the problem. And we're not really great at working with fractions. We're better at regular numbers, right, than we are fractions. Everybody is, okay? So we want to try to be smart about what we solve for. So if I subtract or move that 2y by addition, that's going to change this problem to be x equals 2y minus 6, right? Now I have one of the variables by itself like I did on the last two problems, right? I can take that and do what with it? Substitute it for right there with the x and the 4x, right? So that's going to be 4 parentheses 2y minus 6 plus 6y equals 4. So we replaced or substituted 2y minus 6 in the place of x. Now we got an equation that's only got y's in it. So we just got to work that. Distribute. 4 times 2 is 8. 4 times negative 6 is negative 24. Plus 6y is equal to 4. Can we combine some like terms over here? 6y and 8y is 14y minus 24 is equal to 4. Add 24. How much is that? 28. Last step. Divide it by 14. Y is 24 divided by 14. Does it go evenly? Let's see. Okay, so let's just reduce that fraction then. 28 and 14 are both even, right? So divide them by 2. So that'd be 14 and 7. Does 7 go into 14? Yeah. How many times? Why? So it turns into 2. So that means 28 divided by 14 would be 2. Okay, so there's y. How can I get x? Yeah, I can put it back in my equation that I made with x equals, right? So I got that equation that said x equals 2y minus 6. I'm going to take this and put it in for y so that it's an easy solve. So 2 times 2 would be 4 minus 6. What's 4 minus 6? Just 2? Negative 2, because the 6 is bigger. So x is negative 2. What's the ordered pair? Negative 2, positive 2. Again, that ordered pair is going to be our final answer when we're doing this. Not bad, not bad at all. Say we had 3x plus y equals negative 7, and negative 2x plus 4y equals 0. What can I do to this one? To help me solve it by substitution. I can subtract 3x and it would get what by itself? Why? Why do I want to get this y by itself? Because it's got what in front of it? A 1. That's why we want to move the 3x for this equation. We don't want to use this one because it's got numbers in front of the x and y. Okay? Sometimes we have to, but we got an easier route here, so we're going to take that. So we're going to subtract the 3x, like y'all said. So there's y by itself, and negative 3x minus 7. Tyler said you plug that into the second equation. in the place of the y. Multiply. It'll be minus 12x minus 28. What's negative 2x minus 12x? They're both negative, so it's going to make them more negative, right? It'd be negative 14. So it's like you owe me $12 and you borrowed 2 more. Now you owe me $14. Almost there. What do you do next? Add 28 to the 0. So negative 14x is equal to 28. The last step, divide by the negative 14. X is equal to what? Negative 2 this time. How do I get y? Plug it back in to this problem up here. Negative 3 times negative 2 minus 7. Negative 3 times negative 2 is positive 6 minus 7. 6 minus 7, negative $1. Ordered pair. Negative 2, negative 1. Okay. Not bad. Getting there. All right. Say we had this system. Let's say we had x plus y equals 5, and then maybe had 2x plus 2y is equal to 13. That's a good number. What can I do? Which one would I want to work with? The top one looks like the one that I'm going to work with because what's in front of x or y?
1.
Ones. Okay, so it doesn't matter which one I solve for.
No.
No. I don't care which one. Which one do you guys want to solve for? The x? The top one for x? That's fine. We can do that. So let's do that. How do we solve the top one to get x by itself? Minus y. Good job. So that's going to be x equals negative y plus 5. What am I going to do with that part? Plug it in for x. So that's 2 parentheses negative y plus 5 plus 2y is equal to 13. Okay. What's the next step? Multiply it out. So that's negative 2y plus 10 plus positive 2y is equal to 13. Yeah, put the two y's together. So we got negative 2y and positive 2y. What happens to those? They cancel out. Uh-oh. So that's 10 equals 13. Does 10 equal 13? No. This is not true. This is a false statement. Anytime all the variables cancel out, you look at what's left. If it's false, no solution. Okay. But you've got to have all the variables canceling out. If there's a variable still in there, it can't be no solution. Okay. So here, just a special case where we got the variables to cancel out. Okay. Sure. That happens. let's say we had this 3x minus y is equal to 6, and then maybe we had negative 6x plus 2y is equal to negative 12. So which one would be the best to get a variable by itself? Solve for y on the top one, because it's got a negative 1 in front of it. So that's pretty easy. That we don't have to do a whole lot of stuff to get that done. So let's do that. How do we do that with the first one? Nope. What sign is the 3x? It's positive, so we're going to subtract it. So that's negative y is equal to negative 3x plus 6. Is y by itself? It's got that negative 1 in front of it, so we need to get rid of that. So how do we get rid of this negative 1 that's right there? What's going on between the negative 1 and the y when they're mashed together like that? They're multiplying, so you need to divide by negative 1. So that's going to give us y equals positive 3x minus 6. Then we're going to take that in and put it in for y in this equation. So negative 6x plus 2 parentheses 3x minus 6. What's the next step? Well, distribute that 2 out. So we got negative 6x plus 6x minus 12. I don't know why I put that equal to 0. It's supposed to be equal to negative 12. Equals negative 12. What happens to the x's? They cancel out. Is negative 12 equal to negative 12? Yes, always. So this is true. So it's an infinitely many solutions. And I'll let you guys abbreviate that IMS. You can write that. Like, it doesn't happen very often anyway, but when you can use the abbreviation IMS. Okay. So we can have one solution. That's where you're going to have the variables are left in there. No solution and infinitely many solutions, the variables go away. And you look at what's left. If the numbers are equal, it's infinitely many solutions. If they're not equal to one another, it's a no solution situation. Those are the things that can happen with solving systems. By substitution, this is the way it looks when we do elimination. Friday, you will see similar things happening. I'll show you how to do that. It's not difficult. Hopefully you've seen it before. How many people have done substitution before? Most of us have it, or don't remember doing it. Maybe you just don't remember doing it. This is something that we normally cover in junior high math. Just